here's an experiment to lessen vertigo in space when trying to create artificial gravity using centrifugal force. Now, a problem in space is astronauts in zero-G gravity, they have like bone and muscle loss. In fact, they say the people who go to Mars and try to colonize Mars, it's going to be a one-way trip just because the difference in gravity will mess up the body where they will not be able to return to Earth. And a solution, of course, is having artificial gravity in space using centrifugal force. So in this illustration by Gene Watson, it shows what you could do to experiment to lessen vertigo and create the right amount of artificial gravity, mimicking the gravity we have here on Earth, or the sensation of gravity. So in Earth orbit, you get two space capsules, and you connect them by a cable, and you start rotating the capsules. And the center, it's kind of like a merry-go-round. One capsule's on one side, and the other capsule's on the other side, and it just rotates around. And then you could adjust the length of the cable to find the right amount of centrifugal force that does not create vertigo. And this experiment is to settle the vertigo myth in space. That's what he said. He said it's a myth that artificial gravity will automatically create vertigo. Well, it's not necessarily the case if it's done right. So he further describes it in an email. Obvious connect two manned space capsules by an adjustable cable afterwards removed. So you would have an adjustable cable, then you would remove the cable and just let both capsules rotate. He says the Russians can do this easily with their space program using two launches. Then they can experiment in the sitting and standing position if they have vertigo. If it diminishes with distance from the center of rotation, and how much distance from the center of rotation is minimum for the body to adjust and not feel vertigo. So they would kind of experiment sitting and standing up and adjust the distance so they're not really feeling that much vertigo or feel no vertigo. From practical hands-on experience, when I was a teenager on park rides, vertigo lessens with distance from the axis center. It would not be a problem as big as rotating spaceship would be, especially if people could see outside the spaceship by a plasma screen camera picture, rotation that cancels rotating motion in picture. So what he's trying to say there, so the spaceship would have artificial gravity, it would be rotating, but like on Star Trek, if you look out the window, you just see space like you're flying level in space. You know, the stars, the moon, everything would appear like it's not rotating. And this would give the body your perception, this would give you the perception that you're not rotating because it looks like you're looking out like an airplane window or just a window of a building and everything is level. The real reason for this objection is economic. It costs more. The advantage is not aesthetic, but necessity. Artificial gravity prevents bone and muscle deterioration. So, yeah, I mean, a craft with artificial gravity that has to rotate, and there's a screen capture. I think that's from 2001, A Space Odyssey, where they kind of captured a spaceship with rotation, artificial gravity. It would not be aesthetically pleasing, but it would be a necessity because you need something that rotates where it mimics gravity on Earth, so you don't have the harmful effects of zero-G, and you need to, he says, by adjusting the distance, you could cancel out vertigo. So that is the artificial gravity experiment in space to cancel out vertigo.